Hey guys, so based off of the Pythagorean theorem investigation that we did, this is just going to kind of be wrapping it all up together for the models that you're expected to see. So basically, when we were looking at your models, you determined that if we look at this square right here, it has a side length of 3, but it has an area of 9 because 3 times 3 is 9. This one has a side length of 4, but an area of 16. And this one has a side length of 5, but an area of 25. And what you discovered yesterday was that if I add my small square and the area of my small square and my medium square, it equals the area of my largest square. So if I take 9 plus 16, it should equal 25. 9 plus 16 does equal 25, so I know that those 3 squares would create a right triangle if I put them together. So if we want to try and determine what a missing side length would be, for example, right here, if I want to know what this missing side length is, I need to first find the areas of both of these. So if I have a side length of 7, if I square that, it gives me 49. If I have a side length of 25, if I square that, it gives me 625. Now, in this case, they give me the largest and the smallest. So if I know the largest and the smallest and I need to find the medium, typically I add these two together. So if I would have taken the area of the smallest one plus the area of the medium one, it gave me the biggest one. To find the medium one, I've got to subtract. So I'm going to do 625 minus 49, which gives me 576. Now, that's giving me the area. I don't want the area of it. I want the side length of it. So just like we've been practicing about how if I'm given the area and to find the side length, I'm going to have to take the square root of 576, which gives me 24. So I know the missing side would be 24. Okay, if I look at another example, this one, they're giving me the small and the medium, and I need the large. So I know if I can find these two areas, then I can find the area of the largest one, take that square root and find the side length. So the area of side A, that square, if I do 14 squared, it gives me 196. 20 squared is 400. So if I want to find the area of the biggest one, I'm going to add those two together and I'm going to get 596. Now, I want the side length, not the area. So to find that side length, I'm going to have to take the square root of 596, which gives me 24.4. Okay, on this one, they give me the areas and they're asking about the side length. So when we were talking about how it's important to be able to identify if they're giving me area or side length, again, they were very clear and labeled it area, but they also put units squared to indicate that they had given me the area. So if I know the area of the small and the medium one, I can add those areas together and I get 117. Now, if I want to know the side lengths of each one, I've got to take the square root of 36, so it gives me a side length of 6. Square root of 81 gives me a side length of 9. And the square root of 117, which gives me a side length of 10.8. On this one, they mix it up a little bit. They give you the area of one and the side length of the other. To be able to work with this, I need to know the areas because we've not ever been adding or subtracting side lengths. So I need to know areas. So I need to find the area of the largest one by doing 17 squared, which is 289. Now, typically I would add the small and medium one to get the largest one, but since I'm missing the medium one, I'm going to have to subtract 289 minus 64, which gives me 225. That's the area. I don't always want the area. I want the side length. So to find the side length, I need the side length of the small and the medium one, so the square root of 64 is 8. The square root of 225 is 15. So that is giving you basically a good little intro again of all the different things with that. So just to go back over some important vocabulary, our vertices are our corners. Let's zoom in a little bit here. Corners of a shape. Squared means we multiplied a number by itself. And just a refresher again of what we've been doing, the area of the square, we found that by doing side squared. So if I want to find the area of this one, I know area is side squared. If my side length is 6.1, I'm going to square that, and it gives me an area of 37.21 inches squared, and that's how I indicate to somebody that I gave them the area. Then if it wants to tell me the side length, again, area is side squared. This time I have 115, and that is equal to side squared. So basically I squared something to get that area, so I've got to take the square root of that. So the square root of 115 is 10.7 centimeters, and that gives me the side length. Again, I am not ever dividing because I did not multiply by 2 or 4, so I cannot divide. Now, you basically discovered the Pythagorean theorem when we were doing this. So we can find the missing side of a right triangle using Pythagorean theorem, but we're not going to be super formal with it right now. We're still kind of using that idea of the areas of our squares. So side A, when we square that, that is the area of A. Side B, so that is the area of B, equals the area of C. Now, if the area of A and the area of B does not equal C, then it is not a right triangle. Okay, so you basically, if they're giving you a missing one and they're telling you it's a right triangle, you then can either add or subtract depending on what it's looking for. So basically, if I take this, I know I'm going to have 9 of these that are this color. And then if I take these 16, I will have 16 here that are this color. And it just goes to prove that I have the area of A plus the area of B gave me the area of C. Now, if the area of A plus the area of square B equals area of C, then the 3 squares will form a right triangle. Now, the hypotenuse, that's the fancy word that is across from the right angle. And basically what that means, if I draw an arrow, I'm pointing towards the hypotenuse. And it is always the longest side of a right triangle. Your legs are the sides of the right triangle that form the right angle. So this is a leg and this is a leg. So you are always able to determine which one should be your biggest one, because if you draw that arrow directly from that right angle, it always points to your biggest one. So the diagram shows squares R, S, and T joined at the vertices to form a right triangle. Fill in the blanks to make the following statement true. So the sum of the areas of square R and square S is equal to, we don't need than, the area of square T. The area of square T is always going to be your largest area. So if they're giving me the areas already, remember I can identify if they're giving me the area or not because it has little squares here. Okay, so on all of these, and they're asking for, this one they're asking for area, this one they're asking for area, but this one they're asking for side length. So that means that's going to be an extra step for me. But if they're asking for area, I'm literally just adding these two together. So 10 plus 15 gives me 25 inches squared. And it asked for the area, so I would just have 25 inches squared. Okay, on this one again, they gave me the area, so I'm just going to add them together. So 105 plus 22 gives me 127, and that's going to be feet squared. So I know, ooh, I messed up. Hold on. I wasn't careful. See, this is why drawing the arrow is very important. I just proved to you. So always draw that arrow because it will always point to your biggest side. So on here, I'm not going to be adding these two because they gave me the biggest one. They gave me my hypotenuse. So I'm actually going to be subtracting these. So I'm going to do 105 minus 22 because I should have added the two smaller ones to get the biggest one. So I'm going to do 105 minus 22, and that gives me 83 feet squared. Now, this one, I'm looking for the biggest one, so I'm going to add these two. But this is the one where we have to do that extra step because they don't want the area, because when I do 32 plus 40 and add the areas together, I'm getting an area of 72 centimeters squared. But it says it wants the side length. So again, if the area is 72 centimeters squared, to find the side length, I'm going to have to take the square root of that 72 centimeters squared, which gives me 8.49 centimeters. So I know the side length is 8.49 centimeters. So it is all about being careful about, is it asking for the area, is it asking for the side length, and what is it giving you? So on this one, they are giving you area, but giving you area and side length, they're mixing it. So I need the areas to be able to compare it. So if I have 3 yards, I need the area here of 9 yards squared. I got that by doing 3 squared. Now again, they gave me my small one and my big one. So to find my medium one, I'm going to have to do that 9 yards squared minus 3 yards squared. So that gives me 6 yards squared. And it's asking for the area, so I'm leaving it as the area. On the next one, they did the same thing. Again, they gave me mixed area side length, and they're asking for the smallest one. So I'm going to have to do 10 squared here, which gives me 100 inches squared. And then it's asking for the small one this time. So I'm going to have to do 100 or 150. I have to take my largest one minus my medium one, and that gives me 50 inches squared. But it's asking for the side length. So this right here is the area, but I need the side length. So I'm going to have to take the square root of 50 to find the side length, which is 7.07 inches. So I know the side length of this would be 7.07 inches. And then on this last one, again, they gave me mixed numbers. They gave me area and side length. So I'm first going to have to find the area of this one and do 16 squared. So that gives me 256 millimeters squared. I'm looking for my largest one, so I'm going to add these two. So I'm going to do 350 plus 256, and that gives me 606 millimeters squared, and it asked for the area, so I am done when it asked for the area. So 606 millimeters squared. Okay, so you will finish up whatever else you need to do for today. Have a good day.